Hi everyone, we have another beautiful polynomial equation here before us here. How do we solve this? Look at the question. The question is t to the power of 24 plus t to the power of 16 equals to 80. What is the value of t? If you check out this question, it shows or means that you have to solve for at least 24 roots to this challenge. But here we're going to consider, I think, the real roots. We have to solve for only the real root. So how do we get the real root? So let's go on this journey smoothly together. So we have solution. All right. Look at this power here. We have to rewrite this power. We also have to rewrite this power. Yeah, we can rewrite 24 as 8 times 3. And we can rewrite 16 as 8 times 2. So let's go ahead and rewrite this. So this is going to give us t to the power of 8 all raised to the power of 3, then plus t to the power of 8 all raised to the power of 2. This is equal to 80. Okay? According to the power law of indices, we can use this exponent to multiply this exponent. That will give us 24. We use this to times it. That will give us 16. Good. Now move this quantity to this side of the equation. So this is going to give us t to the power of 8 all raised to the power of 3, then plus our t to the power of 8 all raised to the power of 2 minus our 80. This is equal to 0. Okay, so what we do next here now, we just have to think of what to do. So long what we have here and what we have here are the same, and we can form another polynomial which is of third degree. From this system, that we do some simple substitution. And so we can say here, let our t to the power of 8 be equal to p. So wherever we see t to the power of 8, we put in what? P. So this now implies that our p to the power of 3 there plus our p to the power of 2 minus 8, this is equal to 0. Like I said before, this is a third degree polynomial equation. We can solve this using two approaches or two methods, in fact, three methods. Yeah, all we just need to do is to find the factors of 80. Then we think of substituting one of them into this system to get the zeros of this. And if you do that carefully, you discover that 4 is going to give us a pattern. From there, we do a long division method that will enable us to get the other two roots to this challenge here. But here we're going to use a different approach here. What we're going to do here now is to rewrite this 80 with respect to this power here and this power. So minus 80 can be written as minus 64 minus what? 16. Okay, good. So if we do that, this is going to give us here our p to the power of 3 there plus our p to the power of 2 there minus bracket here. We have 64 there plus 16. Close bracket, this is equal to 0. So when we open up, we're going to have p to the power of 2 plus, to the power of 3 here, then p to the power of 2 minus 64, and minus 16 equal to 0. Again, I said we decide to choose these two figures based on the power we have here. So what is 64? 64 can be written as 4 to the power of 3. And 16 can be written as 4 to the power of 2. And because here we have power of 3, let's marry this one that can be written as 4 to the power of 3 with this and this with this. So rearranging this is going to give us our p to the power of 3, then minus 64, then plus our p to the power of 2, then minus 16 equal to 0. So rearranging them or rewriting this in terms of the base numbers, so we're going to have here our p to the power of 3 minus, this is power of 3, minus 4 to the power of 3, then plus our p to the power of 2 minus our 4 to the power of 2. Right? Then equal to our 0 here is equal to 0. So we can put this in bracket, put this in bracket, right? Good. So, okay, so if we decide to take this as our p to the power of 3 minus our 4 to the power of 3, let's separate this, and we separate this bracket our p to the power of 2 minus 4 to the power of 2 bracket. This is now let's look carefully here. If you share this is what we call difference of 2 cubed And this is what we call difference of 2 square. What does that of 2 cubes say? It says that if you have your x to the power of 3 minus your y to the power of 3, this is equal to bracket your x there minus your y, close bracket, bracket your x squared, then plus your xy, then plus your y squared, close bracket. The difference of 2 squares says that if you have your x to the power of 2 minus y to the power of 2, this is equal to bracket your x plus your y, close bracket, bracket your x minus y. So from here, let's keep these guys aside. Let's rewrite this and rewrite this. So rewriting these two, this now implies, yeah, this is going to give us bracket our p minus our 3 close bracket, bracket our p squared there plus our 4p then plus our 4 to the power of 2 close bracket. The plus, let's put our plus here. This place is bad, but let's manage it like that. Then here we take difference of 2 square, which is equal to bracket our p, then plus 4 close bracket, bracket p minus 4 close bracket equal to 0. So now let's look at this now. We are having p minus 3 here. We are having p minus 4 here. Is it 3 we have there? Oh, where did I get this 3 from? Oh, please, sorry. Oh, this is 4. Oh, not mine English. Okay, so we have here p minus 4 and we have here p minus 4. So we can factor p minus 4 out. So this is going to give us p minus 4 close bracket. If we use this to divide this, we are left with this. So we're going to have here bracket. Let's put this in a square bracket. Our p squared plus our 4p plus 16. Okay, bracket plus. If we use this to divide this, we are left with this. So we have here our bracket p plus our 4 close bracket or a square bracket equal to 0. Good. So we can open up this. Then we're going to have our p minus 4 close bracket, bracket. Here we have p squared there plus, do we have any other p yet? So this plus this will give us 5p. Then we have 16 plus this will give us 20, right? So we have 20 close bracket equal to 0. So we apply the 0 product rule. We take this to 0, we equate this to 0. So we're going to have here case 1. Case 1 is going to give us our p minus 4 is equal to 0. So send this to this side. So we have here p is equals to 4. But remember, we do not have p in the system. We have our t. And so we have to recall where we said, let t be equal to this. So let's continue on this side and see what this gives us in turn. All right. Okay, so from here, we now say recall. We have to recall that we said our t to the power of a is equals to what? P. So we have our p to be 4. So let's put in p here. So we're going to have here t to the power of a is equals to our 4. Okay. So we take this, or we raise this to the power of 1 all over 8, this to the power of 1 all over 8. So if we do that, this is going to give us our t to the power of 8 all raised to 1 all over 8 equals to 4 all raised to 1 all over 8. So this will leave. So we're going to have t will now be equal to our, now this 4 could be written as 2, okay, 2 to the power of 2 all raised to the power of 1 all over 8. So if we multiply out 2 here, 1, 2 here will give us 4. So end up having t is equal to our 2 to the power of 1 all over 4. Okay, so this is the value of t that will give us this. But if you check this, this is to the 1 all over 8 of this. So here we have this to be t1 is equals to our plus 2 to the power of 1 all over 4, and our t2 is equal to our minus 2 to the power of 1 all over 4. Okay, so these are possible values for our I. Now you're going to do the check for me. Check this and this if they will satisfy this equation. I'm going to see you in the comment section. Now let's take our case 2. Look at our case 2. There's our case 2 from here. Look at our case 2. Now I have used, I solved this very well, and here gives us imaginary root. So no need solving for this. So here we have imaginary root. We have imaginary root or solution. So no need solving for this. So these are the two possible reroute values to our expression here. Okay, so this brings us to the end of this math challenge. If you learned something from this video, drop it in the comment section. We're going to see you in our next class. But before then, keep winning. And remember, Jakes does loves you. Bye for now.